actions. And I think looking at the list, we already have about 85 participants that have already joined. I think that's a good number. We are going to proceed. This webinar that we are holding today is one of the planned webinars that we shall be having on preparedness for the next pandemic. This is informed by experiences we have had in previous emergencies like COVID and also other disease outbreaks like Ebola. And as part of the implementation of the preparedness flagship project that we call PROS, WHO Afro continues to strengthen country capacities in anticipating hazard and predicting risk to inform policies and transformative propositions in preparedness and readiness ahead of the public health emergencies. This innovation that we'll be sharing today is an approach that involves artificial intelligence, modeling platforms that utilize country information derived from strategic toolkit for assessing risks that we refer to STAR, and country disease-specific historical data to predict the likelihood of the burden of cases and morbidities. So welcome, ladies and gentlemen, and I'll start by introduction. I am Dr. Charles Njuguna. I'm the Regional Advisor on Country Readiness Strengthening based here in Brazzaville, Congo. And on my right is our Program Area Manager, Dr. Dick Chamla. He'll be making a presentation. On the far right, on my side, is Mr. Isaiah Fernandez, who is an artificial intelligence specialist. He will be doing a demonstration. So I would want us to go to the housekeeping slides, please. Can you project? So before we start, ladies and gentlemen, note that this meeting adheres to the code of conduct to prevent harassment, including sexual harassment at WHO events. Just for your guidance, in terms of questions and chat, we have provided you with the Q&A platform, and please use the Q&A platform for questions regarding to the topic and presentation only. For any issue related to IT or logistics, please use the chat platform. That is very, very important because for technical issues, we shall refer to Q&A, and for IT and logistical issues, we shall refer to the chat platform. And we shall allow some discussions at the end of the presentation. Next. For interpretation, ladies and gentlemen, we will conduct the meeting in English, but we have interpretation that will be done in French and also Portuguese. They'll be available. So in your computer, please just click the interpretation button and you'll be able to choose the language that you'd like to hear. To hear the interpreted language only, click mute original audio. Please note the proceedings or the interpretation of proceeding serves to facilitate communication and does not constitute an authentic or verbatim record of the proceedings Only the original speech is authentic. Next. This session is being recorded and we take your attendance as consent to be recorded. Recordings will be shared after the session in English, French, and Portuguese. Session materials, including session recording, will be emailed to the participants in the days following the webinar. Thank you very much, ladies and gentlemen. And now it's my great pleasure to invite Dr. Dick Chamler. Welcome.
I really appreciate that, Dr. Njuguna Charles, for the introduction. I think I'm glad to see we have an excellent attendance up to now in the beginning. And the ladies and the gentlemen, the colleagues, preparedness enthusiasts, it's a great pleasure and an honor to be here actually with all of you. And I will start with the greetings from Brazzaville and the bon dia in Portuguese and bonjour à tous in French and the men hao in Chinese. Okay, esteemed colleague, a year ago here in Brazzaville, we launched flagship programs. And in Africa, the EPR flagship programs, they are flagships for preparedness, which it is abbreviated as PROS. And one of the critical objectives of the PROS, it is to anticipate risks ahead of events. And ladies and gentlemen, here today, it is one of the webinar series which will be starting on preparedness for the next emergency. And in the presentation today, we'll be talking more on the innovative platforms in which WHO Afro has been engaged in order to help our member states to be able to early prepare in order to respond. And as you have heard in the introduction, we have relied on the data from the member states, and a lot of information in which you hear here, it will come either from historical data or from a report of the STAR in which a number of our countries have already done. So today, if I will start with this presentation, I will be talking about 3 important projects and the underlying assumptions for all this development of the models in which we'll be presenting to you is actually presented in a slide there. We all believe that emergencies do not happen at random. It has a cause, it has explanation. If we take example, a disease, we believe it starts with a pathogen. And after having the pathogen, there are transmission dynamics in which involve either person to person or from animal to person. And if you will have in this transmission dynamics an increasing numbers of cases in excess of expected incidence of a disease, we categorize it as an outbreak. And when you have an outbreak, you have an increasing demand of healthcare. And in turn, we have to develop a number of tools in order to collect data. A number of you understand if you have the cholera outbreak example, and we create a line list. And from a line list, we have a robust set of data in which in our modeling, we analyze from the statistical packages point of view, in which we had this statistical product into artificial intelligence apps. And from artificial intelligence apps, we had the results in which it will enable all of you member states to actually decide in terms of the policy or in terms of priority preparedness actions in which have to be in place ahead of an event. Please, next slide. Okay, 3 projects in which I was talking about here. I will start with project 1. We will talk about projection, actually, disease projections. And in this disease projection or predictions, we will be using an example of the cholera data in which we have access from EU member states. And the architectural design of this project is actually having the data aggregated actually weekly, having it in an Excel format, uploaded in the appropriate platform, particularly a RIMA statistical package in which is helping us determining time series analysis. And after that, we upload it to our artificial intelligence algorithms or apps in which it created a projected trends in which we want. So a next step of this in which is so critical to do this, we will be able to determine the modeling of the package of preparedness action in which it's needed to flatten the curve. Therefore, it is actually where we are heading. And the project 2 is on the risk calendar alert emails, in which are automated emails, which you'll be receiving 2 months before hazard happens. And you know, in your STAR reports, you have established a risk calendar in terms of the dashboards. And now we'll be reminding you actually 2 months before to let you know that in your country, you have the hazard with the highest risk is coming. And here is a package of actions in which you should consider. And the excellent part is every country in which have done a STAR, it also been able to develop the multi-hazard plans, or for nowadays, it has another name, NEROP. And from the multi-hazard plans, it will enable you to select the menu of actions in which you'll be able actually to address specific hazards. And there is also architectural design of that. And the last project here, the regional actually atlas, in which we'll be demonstrating how all the risks, either high risk, low risk hazards, are displayed in an African map, in which we have also embedded a real calendar in which we will actually demonstrate on how it is working. Please, next slide. How are the results if I start with the project 1? I think you will hear it more on the underlying the methodology from my colleague here, Isaias. However, how it will be demonstrated in the dashboard is actually how it is reflected here. A blue trend is actually actual data in which have been collected from the cholera. And here is the data of the cholera from a DRC, okay? And the red projected trend, it is actually how our app, our method and our platform, it will project at the cases of the cholera in the next either 20 weeks or maybe 10 weeks as you desire. I think in the demonstration from ICIS, you'll see how interactive it is. I need all of you to have take a closer look on the model accuracy on top, because the model accuracy, it depends on the quantities of the data in which you'll be supplying and the other risks in which are associated with the occurrence of the event. So example, in the cholera, our artificial intelligence algorithm is telling us if we will be adding climatic data, therefore meteorological data. If you add other risky factors, we will be able to increase the accuracy. Our expectation is, or our hope is to have an accuracy level of between 85 to 90%. If we have higher than 90%, it will be closer to reality. So please, next slide. The next slide. Okay, so on the project 1 again, on that already projected trend, it is also reflected actually bigger in the dashboard. And here I've explained 2 projected trend on the number of cases on top, and below is the number of mortalities in which we're expecting to happen in the DRC if you don't really do aggressive preparedness action now. Therefore, and as you see, if you will be in your computer and you have the cursor, I think at the time you roll over the cursor, it will tell you precise number and the confidence intervals. Therefore, here, as I've alluded earlier, my aim or our aim in the next stage is to ask ourselves what kind of packages and the combination of preparedness actions are always needed to flatten actually a trend as you see it. And is actually, it is part, of the next stage of the project. Please, next slide. So on the outcome of the project 2 is, as we say, it will be an automatic alert in which will be receiving automatically. And in the demonstration here by ISIAS, we will ask a number of you from the countries, to email us or to even actually text your email address, in the chat box in order to also have a look how email are actually happening. And here a flow chart of the events. We have a data in which we take it in a Power BI platform in which we uploaded everything and configuration into automated Power platform in which you will have triggers, and from those triggers you will have your email alerts. And in your email, you will have email actually with the PDF attachment. Next slide, please. In the PDF attachment now, here it is an email in which you receive if you are the person from the country office. Therefore, the page 1 of the PDF attachment, it would be a brief summary of who the country where it is, and also the list of hazards with the highest risks in a particular month. And you'll have email up to 2 months prior to this hazard, because we estimated 2 months is actually adequate time for our member state to have actions in place. The page 2, it will be, it contains the table actually with the details in each of the few months preceding actually the months of the highest risk. And here, I'm sure all of you who have conducted a STAR report, you'll be realizing that. In the body of email itself, we will tell you, please take appropriate action, and we'll be able to refer you either to your multi-hazard plan to decide your action, or if you have already done the readiness assessment, we tell you try to use that. Or if we have any other tools in which the member state have, we will ask you to also refer. Please, next slide. Our people in the regional office, in the email attachment, it will actually appear like this, because in the region, we have to understand on the number and the multiple countries in which we'll have actually hazard and highest risk. Therefore, we will be designated our people who will be actually trying to monitor. And in the region, it will help us to also mobilize the technical support needed, all resources in which we'll be interested to mobilize at that time to support particular countries. And as you see, each of the hazard is the color coded, to which it will actually enable our expert will be prepared. Please, next slide. Okay, on the last project is the Regional Risk Atlas. And as you see here, we've only tried to demonstrate, I think, one map only with the, actually with the hazard with the highest risks. And you are right, you also realize we have a calendar. And it is extremely critical to have a look inside on the calendar. You will have an option to add actually events in which you are planning to conduct in your country. Because if you know in October, example, there is a higher risk of the cholera, and you are planning to organize the regional meeting, I think we will tell you in the next 2 meetings, in the next 2 months, you'll have high risk of cholera. Please try to consider if you are still interested to conduct the regional meeting in which we will bring everybody. As a result, it will help you because in Rio example, we had the country at one time. It was organizing the region, a global meeting of actually UNESCO, and we had MPOX happening, and then it became a political issue. How are you able to postpone the meeting in which it's already planned? Because now there's an issue of revenues associated with it, issues of tourism, etc. Therefore, now you have option to plan ahead. If there is a higher risk of a disease in a particular month, actually 2 months you have to decide if you are still planning to have the larger meeting in the months in which you have a higher risk actually or not. Next slide, please. And the previous one, it was an online interactive risk atlas. And here we are offering you now the offline option actually of the risk atlas on the risk calendar. If internet or if you have issues to have access to the professional Power BI to operate actually an interactive or interactive platform, you are able to print is as an offline calendar, printed it and have it on your wall, and it will be enabled for you also to understand easily, to flip out your calendars, and every month you'll see how you do. And please, it is easily customized for your country to ensure critical dates and events are also included in order to plan better. Okay, what are the next steps now? So on the next steps, as you see, I think one of limitation we have on the STAR exercise is we always have STAR reports at the national level. I think it would be appropriate now to start to consider conducting STAR at subnational level, because now it will enable you to understand which are the districts or provinces in which a particular hazard is. And at the time you create these calendars, it will enable you to understand where are the events. If you're planning to have events, instead of having the event in one of the districts, it will enable you to have the event in another district, okay? As a result, it's only one country now in Africa in which have already expressed interest to conduct a subnational STAR, and the country is Angola. And our team here actually is already started to see how are they able to actually help on that. So we have also CAR of recently have asked us if they're interested to do a subnational JEE. As a result, we are actually seeing now a number of the countries in which are interested to apply all these, the national global tools into actually a subnational level. And as a next step, actually, as I've told you, in order to increase accuracy of our prediction, we need to have the meteorological data, particularly on the cholera. As you know, every person now is interested with the issues of climate change. Therefore, I think it would be appropriate if you member states and us, we have to work together and actually see how we'll be able to have access on climatic data. The other action plan is we have tried to have all the platform here from open source actually softwares. Therefore, now we are planning to have a proper development of an app actually in which we'll be able to deploy it in our member state. And accompanied to it also is actually the mobile application. So as if you have an expert, you're able to apply it at community level as well. And the other one is really in a long-term planning here is actually predicting new hazards attributed to climate change. I think you understand with this increasing topic of climate change, there is a migration of the birds, particularly from one place in order to have the breeding sites. And in our year, you all understand we have the Marburg in the countries in which actually hasn't happened before. As a result, we are trying to do the modeling in the future. It's actually predict where are the new hazards will happen. And we'll try to work with other academic institutions to help us on this. And the last one is, as I've alluded areas, we have already started brainstorming on the modeling of the package of preparedness actions in which it will help us to flatten the curve. All we are really doing here now is to see how preparedness will be able to be closely linked with response, because all we are doing now, if we have the right preparedness action ahead of events, we will have higher impact on reducing a number of public health emergencies in Africa. Okay, now I will hand over to the moderator to welcome my friend Isaiah to have the live demonstration. Appreciate and obrigado. Thank you very much.
Thank you very much, Dr. Dick, for that very interesting presentation. Indeed, these are efforts that are going to help us in our region to be able to handle public health emergencies in a better way. We all know that Afro region, every year we have over 100 events, public health events. And therefore it's very, very important for us to have systems that are working. And as Dr. Dika has said, having prediction that is functional, that is working, it links to preparedness. It helps us to prepare better. And from there also, we will be able to do better readiness, and we will be able to also have better response to public health emergencies, which will help us in reducing the morbidity, mortality, reducing the socioeconomic consequences, reducing the time frame we are using for public health emergency response, and also reducing the resources that are being deployed in terms of human resource and also the finances. And now it's my honor to welcome Isaiah to do a demonstration on these tools, how they are working. Over to you, Isaiah.
Okay, thank you very much, Dr. Charles. Thank you, Dr. Dick, for the presentation. Welcome, colleagues, and thank you all for joining. So I'll be going through some demonstrations. Some of them will be live. I will need your participation, as Dr. Dick mentioned before. We will need some emails, and we can actually do a live test so we can see. So I will start with project 1, which was the prediction, and we used cholera. Some of this data was used from the countries and the partners. You shared this data with us, and it was then combined. We got data that went from 2019 to 2023. Of course, the more data we have, the better it will be. What we did then, we combined, merged the data and imported, we used Python to code. And some of this data was then combined and brought into this platform, Jupyter, for prediction purposes. The very first page, or the very first row, shows just a little bit of the data that was combined. We did some exploratory data analysis to understand a little bit of the countries, cases, and deaths, and a little bit of visualization also to understand the patterns for DRC specifically. And then, of course, we did for other countries. The most important part was the predictive analysis section. We could have used several models, the Bayesian. We used ARIMA because we have a time series or seasonality. So ARIMA was the best to use, the autoregressive moving average, which is the data of the model that was used for this particular one. ARIMA, probably won't go into much detail. We had to figure out the stationarity. And this is what happened for the stationarity. We had to check for autocorrelation or partial autocorrelation to check exactly if the data was balanced, and to be able to determine which parameters to use and which parameters were best to use to give the most accurate prediction. After the parameters were fixed, we try to fit this model into what was used for predictions purposes. Voila. Okay. So we have a graph here, just in the beginning, as a test, one of the first tests to run, for prediction for 12 weeks. This blue side was the data that was gathered before the 2019 on to now, and the red section of it is the predictions after. And we did this both for the cases. This is here for 12 weeks, and we did it also for the deaths. Now, the most important part after doing this analysis in the machine learning app, it was then deployed uh, to another app, which I will show. And this is the app that Dr. Dick mentioned that is very interactive. This dashboard, it's extremely interactive. This dashboard, so the same data used and then run through testing and training was then deployed to this app. I've already put the data here. And like we've been using DRC cases. We've done all countries' cases and deaths just to see. And then we did a forecasting. So we can use the forecasting. Um, uh, oh, sorry. I mistakenly changed. Okay. So, and then let's say we do for 20 weeks prediction, and then we run the analysis. So for this 20 weeks prediction, once it opens up, okay. So the bottom part is where it was presented on the presentation by Dr. Dick. The blue lines to the left of the red were data that we have, that we collected and merged from 2019 on to most current data. And then the prediction, the part ahead, which is the red. In summary, this is the overall. In summary, this is uh, the data in big, so the red part. As we hover over, we can see the countries and the dates. This goes by weeks, and it tells you a prediction. For instance, now, November the 3rd, it forecasted to be about 1,165 cases. And then it has the confidence interval. And of course, the confidence interval, if you see, is not very, it's a little bit broad, but it just depends on how much data we can have, especially weather data, if we can incorporate to get this model's accuracy to raise, to be a little bit bigger. So it's very interactive. We can get any other countries. Here we're doing cases. Can go to DRC deaths, so you can see a little bit. And also let's do forecast, and let's just do the 20 weeks as well. And the 20 weeks, same thing. As far as the accuracy, 63%. It was a lot lower before because we only had cases, data before from 2021 to 2023. The accuracy was a lot lower. It was on 40 something. When we got data dating back to 2019 onwards, the accuracy improved. This is just to say that the more data we have, the better it will be. Oh no. I'm sorry, my computer just shut off, but it's coming up. So we were on DRC deaths, just to show a little bit of the deaths. DRC deaths, and doing a forecast. Okay, and so the forecast for DRC deaths as well. Data, when we collect the data, as I was saying before, when we collected 2019 data, the accuracy went from 40 to 60. This is just to say that the more data we have, and of course for cholera, you know that environmental factors play a big role, like rainy seasons, so the accuracy will be better. This was project one, and this is an interactive tool that was then deployed for the specific purposes. Also to state that this is not only adaptable to cholera, it could be adaptable to other diseases as well. So when we go to the second, our second project, or project two, we had data that was gathered from STAR, from the partner countries. This STAR data, after collection, the biggest deal, or the biggest objective, was to get notification for countries to get notified of potential hazards or upcoming hazards. Countries' reports were already done before. What happened on Power BI desktop, there were, in order to create that, there were KPIs or cards that had to be created for each country, for each hazards. It was an intensive work. The creation of that, we had to do thousands of KPIs and cards, then take from Power BI desktop into Power BI service, pin every visual card, and then create an email alert whenever a threshold was reached to send out emails. And then we went a little bit further to automate this, where we did the Power Automate. So here we see the Power service for each country. Power service, and we see all the countries here listed, and the configuration had to be made. Now it's been configured, whereby each month we here at Afro, you, the colleagues in the countries, will be receiving emails and alerts with a report stating or showing which hazard is yet to come, so you can prepare. This is the time where I would like, if some colleagues can share their emails, at least one email from focal point from your country, perhaps I would say, I don't know, a Zambia or a Malawi, and I can do a test right now and be able to send you an email notification of an upcoming hazard in your country. So if you're in your chat box, if you can share an email, and then tell me a country, that would be greatly appreciated, and I could do a live test for you guys. Thank you.
Yeah, thank you. Thank you very much, Isaiah. Okay. Can you do the calendar also?
Oh, I'll do the calendar? Okay.
Okay.
Okay, well, let me show you the calendar. So this is the calendar that was created. Okay. This was the calendar that was created. The calendar shows there's it's been divided into three sections: all risk hazards, high risk hazards, and low risk hazards. The high risk hazards, in order to have all the data, we only have all the data from majority of the countries that dates back to 2022. And here you can see, and if you hover over, you're able to see different hazards. For 2023, unfortunately, there's only 4 countries data that we have. The high risk hazards here, for instance, for 2023, for this month, we're able to see the 4 countries, Burkina, Mali, Cameroon, Gabon, and Rwanda, and their legends, with their upcoming hazard. This is showing September 2023 and its corresponding calendar and of events. Of course, if we move, this is interactive. October, it shows what we'll have in October, and so forth and October here as well. So each calendar, it's interactive and it changes accordingly. This is an online interactive tool we can change and we can update. And as Dr. Dick showed or said before, we also have, if you don't have access to this dashboard, you also have the PDF version or the calendar version, the printable version, where you can print it out and make it adaptable to your country and put information regarding or the most important information for your country in the calendar. Thank you. I'll be waiting for the emails to test, and you'll be able to see live the tests for the calendar. Thank you.
Okay, thank you, Isaiah, for that demo. You can switch off your mic, please. We already have some questions that are coming, and we'll take those questions. But also, if you want to speak, we will give a chance to some people. So you raise your hand. But for now, let me go to the chart. And I would also ask Dr. Bukari to take those that are in French. Yeah? Okay. If they come through, okay, fine. So the first question is from Moses in Uganda. And I can see you have two questions. The first question, in terms of existing strengths, what do we already have at country and what do we require now? I will ask Dr. Dick to take that. And there is also a second question from Moses. Is the prediction possible for other disease conditions beyond cholera? Does the application speak to other platforms already in use for data that is being shared with AFRO, like DHIS2 platform for weekly and monthly data that is shared with AFRO? So it's about the linkages. Then there is a question from Dr. Ambrose Talisuna. What is the minimum years of data needed for the model to be reliable? Isaiah, do you want to take that? Then there is a question from Victor, Dr. Victor Tugumizemu. The first question is, it's commendable to see WHO Afro proactive approach in leveraging artificial intelligence and country-specific data for risk prediction to enhance the impact of these projects. It might be beneficial to collaborate closely with local governments and health and non-health institutions to ensure the seamless integration of predictive insight into their preparedness strategies. Thank you. And you're also asking, could you share insight into the specific challenges and obstacles that WHO Afro anticipates when implementing this innovative project, particularly in terms of integrating AI modeling into country-specific data system and policies? Maybe we can take that for now. Then we'll come to people who have raised their hands. Yes.
Okay, I will start. I see a number of excellent questions here. Okay, if I start with the Moses issue on the strengths and what is already happening in countries and what is missing, I think it's really a great question, and it comes to how we were actually able to develop the conceptual framework of all the projects, because original idea in which we floated, it was at the end of the year actually, and we were able from our teams to actually understand what is present in the country. And we did even a literature view, either from a review, either from a gray literature or electronics, to understand what innovations which are in a pipeline or if it is already published. And also there's a thing in which it drives us to actually do this. It was our flagships, in which also we have agreed in the direction of preparedness, in which our regional office will do. And our direction is to really try to do preparedness on the ground, try to shift from upstream preparedness activities like only IHR core capacities, IMB and others, and actually try to find out what kind of tools in which we'll be able to then actually deployed in the countries to enable them, to analyze on the data in which the countries is collecting. Because I feel we were excellent in, for instance, organizing a risk assessment. And our aim now, it was to shift from assessment to predictions, okay? And in June, we had the meeting with preparedness review meeting in Mombasa with our member states from East Southern Africa. And we also talked actually with our member state on their needs and actually understanding what else Afro is to be able to support. And across the board, across member states, it was actually how to strengthen an M&E for preparedness, what kind of tools, innovative tools, in which we are able to have in order to help the country on themselves to collect and analyze data and be able to actually prepare ahead of an event. As a result, Moses, we actually had really done our groundwork to understand what is present and what are the opportunities in which we'll be able to actually optimize. And also we didn't end up there. We talked to our team here, HIR team in Brazzaville office, in which is connected with Berlin Hub, in which we actually brainstorm what is present and what it isn't present. And we realized that a lot of the tools, it was actually trying to prioritize the public health events at the time they've already happened. And here we say, how about predicting risks instead of predicting events only? And as a result, that is true. But I'm welcoming an idea if we have any other opportunities in the country or if we have any other tools in the country in which we are able collaborating. There have been a number of initiatives with other agencies also in the region. African Union is talking about risk ranking. I'm sure a number of you have heard about it already. And we are collaborating with Africa CDC also in a number of our initiative. We have now the work plan in which we have agreed what are the areas of work in which as a WHO, Afro have to do and Africa CDC actually have to do. I will leave the issue of the minimum years of data required to Isaias. The question from Ambrose. Ambrose actually is a member of our team. I don't know actually why he's asking the question. How are you, Ambrose? Okay, so on the interlinkages also, I think you are talking about operability here with actually with other tools like actually DHIS2, I think is an issue in which we'll be actually looking. Isaiah will be also able to actually to bring that. So anticipated challenges, yes, as I told you, actually our data on STAR is actually at the national level. So at the time we're talking of hazards are not happening in the entire country at the same time. Oftentimes it starts either in a community or it starts in a district. As a result, is the reason our next action, our action point, it was actually how to be able to actually having a STAR at a subnational level. Another challenge is we have started a dialogue with you, all member states now, and I do hope that we will have to have expectation of having a political buy-in on this initiative. We haven't tested also actually to see how interested our member states are. So it is a dialogue in which we have all these projects are only under pilot at the moment. As a result that we will have to have an opportunity to actually have a pilot countries in which we'll be agreeing to actually testing our model. And I have Isaias here who he's a person who is really excellent on these artificial intelligence issues. Actually, he will be also able to let us know what additional challenges he's anticipating. The last thing in which we will be needing is really a buy-in also from our donors. As you know, we are planning to have an app, a dedicated app, official app, in which it needs resources. And I hope even to ask the countries to actually organize a subnational style to also require resources. As a result, it's another issue in which we'll be able to actually overcome. Okay, I will hand over to Isaias if you have an addition. Over.
Thank you very much, Dr. Dick. So I will go into first the integration between the app and DHIS2. There is a possibility in integrating. It is one that I would say it will take time. As you know, both are written in different languages. For the Shiny apps, perhaps if you write it on the R code or R language, and then you put it on the R server and try to connect it to DHIS2. From what I know, DHIS2 does not have the capability of taking in Shiny. There is a possibility of integrating the Shiny into, I guess, another, and then from that integrated into DHIS2. I've not thought about it. It is a possibility, but it is something to think about. The next question from Ambrose, minimum number of years. I would say as far back as we can possibly get, the better and the more accurate the data can be. We can have 20 years going back. We can have 20 years going back. The more data, the better it is. As I mentioned before, especially for ARIMA relies a lot and heavily on historical data and also on stationarity. The more stable data is along the years, the better its prediction. You will just increase the accuracy of the data. So there's no such thing, I would say, as minimum, as far back as we can get, or as minimum. Now we have 5 years. 5 years we were able to get 73 accuracy. So it just depends on the number of years. Moving on to the next additional challenges, I think Dr. Dick already mentioned a few. Only one that I would add perhaps is the consistency in sharing data. We will rely a lot on the countries to share data and for them to be consistent, for us to be able to update. The more the countries give us data, I would say as anyone that works with data, they need data, and the more data we can get, the better we can be at it, the better and the more updated our dashboards will be, and the more we can give an accuracy on the issue. Thank you.
Thank you very much, Dr. Dick and Isaiah, for those responses. Now we would want to also give some platform to colleagues who have raised their hands, and we'll start with Obaroene, then Maolo, then Daniel, in that order. And just please just introduce yourself and indicate which country from. Thank you.
All right, thank you. Good morning, everyone. My name is Obaro. I'm from CHI, Clinton Health Access Initiative from Nigeria. So first of all, I want to say big thanks to the panelists. I think this was really interesting to see. My questions will be for Isaiah, and I think my first question would be on the metric that was used to assess the accuracy of the model. You mentioned that you have 73% accuracy. So was that, say, a root mean squared error? Or because I'm just trying to be a bit technical to understand how the accuracy was measured, given that it's an ARIMA model, and we're trying to predict maybe the number of cases or the number of deaths. Then the second question was really, I think I saw that the code was in Python, but the model was deployed on Shiny app. So was the code later done in Arrow and then transferred to Shiny, or it was in Python and then deployed to Shiny? So those are my two questions. Thank you.
Thank you, Gideon. Just 1 second.
Let's finish the questions first. Maolo, you have the floor. Maolo, can you unmute? Can somebody help Maolo to unmute? Okay, let's go to the next one. Daniel.
Yes, hello. Thank you, Chair. My name is from Uganda. My name is Daniel Eurien. I'm an epidemiologist with the Emergency Operations Center in Uganda. And my question regards now issues to do with data that is necessary for this kind of modeling really requires individual level data. We know countries, I know at least for my own country, Uganda, we have not moved that much in terms of case-based data that would be very necessary for this kind of modeling. So would rely on aggregate data still based on DHIS2. It's only during outbreaks, like the recent Ebola outbreak, where we did some bit of modeling, although we did not go so much into the predictive that have been shown. So my question would be, what type of support would be going to countries to support them now prospectively, now that we know that there are models that are going to be good enough to predict in terms of helping countries now prospectively modernize their data management systems to take in this kind of data that's going to be useful for this kind of work. Thank you, Chair.
Thank you very much. Because I don't see many hands, I think we could just finish the questions from those who have raised their hands. I want to give this platform to Mohammed and then Mary.
Mine was wanted actually to know whether this data is only for the biological hazards, and especially those who are already the endemic or the frequent outbreak. Because if you go for the non-biological hazards, that means like floods, storms, and others. Sometimes they happen not frequently. So are we going to get enough data for that, so that we can also put it in the model and predict? Are we going to use how many occurred, or are we going to use the number of people affected and area affected? But at the same time, we need to know how many episodes do we need so that the model can predict very accurate? Otherwise, we will have very infrequent number of occurrence, which might not be enough for predicting the occurrence of the hazard. Thank you.
Thank you, Mohammed. Mary, you have the floor. Mary? That was Mary Tia. Okay, we are going to go to responses because I think, Mary, I don't know what's happening. So Dr. Dick, then do you have any question?
I am talking. You hear me?
Yes, Mary, we can hear you.
Okay. It's not question, it's an appeal. Whether this thing we're talking about, the preparedness, emergency preparedness for the next climate or so, whether the WHO in Liberia will take these topics to the health ministry to talk to them about it too. Will we be part of the training in case there is training for those countries? How to prepare ourselves in case of any eventuality, whether COVID again, whether Ebola, will we? I'm finished.
Okay, thank you, Mary. Dr. Dick, then Isaiah, over to you.
I think a number of the issues are targeting Isaiah's here. I think you should start Isaiah's and me, I will take on the issue of the training needs.
Okay, thank you, Dr. Dick. So for the first question, the metric used from Nigeria, I think, yes, it was the R2 to do the metric. That was the metric that was used. The Python code that I showed you, that was the second question. The Python code that I showed you was the very first code written when we had the data from 2021 to 2023. Also, when we then got the data from 2019 to 2023, I continued on merging the data and wrote the Python code. For Shiny, yes, of course, it is on R. The equivalent of that Python code in R was written and then deployed to Shiny. Just to answer those two questions. There was another question for the biological hazards, if it could be adapted to biological hazards and the other occurrences, or how many episodes are needed to predict the occurrences. This part, as far as the biological hazards, I think I will send it to Dr. Dick, and then I think he will answer the other ones also. Thank you.
Okay, Mohamed is asking about biological hazards, but I think how we were trying to design this, it was all hazards, biological and non-biological. And the problem in which you have raised is true. We have hazards in which are happening infrequently. And how do we handle actually for those ones? And it's an issue in which we were also brainstorming. And also, as you understand, even our core capacities in the countries, except as chemical radiations, also we are always having problems. So in terms of others like flooding, a cyclone, we were also talking with our HIR, actually colleagues here, is actually to see how are we able actually to create the metrics of that? Are we talking of the number of people who have been affected by specific hazards, or are we really talking about actually in terms of the number of hazards themselves? Okay, is an issue in which we haven't started. We are still brainstorming about it, but I think it is an excellent question in which you've asked. our intention though is to have the model in which will be able or to be applicable in biological and in non-biological hazards. So I'm sure we'll be able to work together on this, and at the time we'll be able to actually have another round, and clarity and consensus among our experts here will be able actually to bring it up to you again and actually have your inputs. Okay, on the training things from Mary, as I told all of you from the beginning here is 3 projects in which are ongoing, and our purpose here is to have your inputs. And we have had an excellent inputs up to now, and particularly on the issue of interoperability here, because we have countries in which already have tools, electronic tools, and we have to know how are we able either to extract data from other tools, or also actually how to link it with other tools. I think it's an excellent proposal here, and I hope we'll be actually able to actually do that, and we will see how it goes. As a result, we haven't yet reached at the stage of trying to organize a large-scale training of the platforms. So at the moment, we are collecting additional inputs, and after having additional inputs, we would be actually asking you guys to let us know if you have any actually to have any country in which it is interested to be a pilot country. And at the time we have a pilot country, will be actually to bring our model on the ground and actually try to do a pilot testing of either interoperability function and others. So I hope at the time we are ready to deploy it as a tool to organize a country training, we'll let you know. We have also another aspect on our side in the WHO. We have also a number of other tools in the WHO in which are also under process. I think some of you have heard of partners platforms in which our HQ colleague have been doing. And now we have the readiness, intelligence tool, in which is already piloted in African in 2 countries or more, I think. And the purpose of the readiness intelligence tool is also to create anticipatory actions at the end of the day. The reason that is our homework here in the WHO, AFRO and the HQ. Actually, how are we able also to create actually interlinkages between tools in order to enable countries to have the platforms in which it will help you? Because at the end of the day, our aim is to really hand over a platform to you country, to you member states, and operate it on your own. Over from me, I think.
Okay, thank you very much, panelists, for those responses. I'll take a few other questions under Q&A. Yeah, people are still asking questions. Maybe I'll take 3 of them, then we can think of winding up. There is a question from Alice. Thank you, this is very interesting. Do you consider include in the prediction some social factors, like for instance, mass meetings, like pilgrimage, sports, World Cup, to come into the next month? The other question is from Sherry. All countries policymakers receptive in using modeling results for evidence-informed decision-making? It's like a question, are countries and policymakers receptive in using modeling results for evidence-informed decision-making? And maybe the last one, let me read from Patrick, because some of these questions have already been tackled. One from Patrick. Were there considerations to unlock potential periods where the case load looked abnormal? From a typical prediction model workflow, were other models compared to ALIMA and conclusion made, ALIMA provided the best accuracy? I think that is for you, Isaiah. So we have those 3 questions. Yeah.
Okay, if I will start, are we able to include other social factors? I think the answer is yes. And from the beginning, I said that from what we've learned, accuracy is likely to be increased at the time you are adding other factors, particularly risk factors in which either has a positive impact or a negative impact on the occurrence of the event. So in terms, example of the cholera, we've already started looking, apart from the climate data, we're also looking of other factors. And here is really a lot of hard working because we have to look at the meta-analysis of other issues like the efficacy of hand washing, of efficacies, and actually having the effective sizes in which it to be able to be included in the model. As a result, we still have other things in which we needed to include. We have here a team now in which is actually trying to look at these issues. And I agree that I think you have brought the issue of the pilmigrade, we have brought the issue of Olympics example. Here are the issues in which here now for in preparedness is a new area in which we are really prioritizing at the moment. Our colleagues in Malawi, I think you remember at the time of the cholera outbreak, we heard there was a traditional, actual a king event which was happening in a district, I think somewhere in Lusaka, Zambia, in which we were highly scared because there was a lot of the movement of people from Zimbabwe, Malawi, Zambia, and other places. And I think our aim, it is also to see how are we able to include the movements as a risk factor, population displacements, and other things. Therefore, it was to answer that. So on the issues of the policymakers, it depends really because at the time we are talking about the modeling for policymakers, yeah, it depends on accuracy, and is the reason we are really talking here how to enhance accuracy. And is actually assumptions behind that, and also a type of the data in which we're including. The policymakers, they have to look things either at the economic angle, is the reason I was telling you at the time we are talking of the next steps is really to do the modeling of the package in which it will have an impact to flatten the curve. Therefore, if we are able to develop a package from clear evidence in which we have from literature, I think one of the issues we are able to conduct is economic analysis, is to only say how much we estimate it will cost actually to flatten the curve. And at the time you tell the policymaker economic implications of any disease or any of our action, it's always have a tendency to actually to increase interest among them. And actually the other issue is if we have any political or ramification or even health impact itself. If we will tell our policy maker from our prediction, we are actually anticipating a mortality to increase 2 times, and actually every person will actually become attentive because the policy makers are always tend to judge health outcomes in terms also actually of mortality. As a result, I feel predicting the cases mortality and economic impact, actually it will have higher chances to actually attract the policymakers to rely actually on the model. And I think I will ask Isaiah now to complete the rest of it.
Thank you very much, Dr. Dick. So the last question that was asked on comparison and with the RIMA, ARIMA was the best one that was used, as it was the one that fitted the best for the time series or seasonality. I did, yes, run other tests, Naves Bayes, Gaussian, ANOVA. They did all not give me the best or the most accurate model, but there was comparisons done with the other models. It was about 4 or 5 models that I ran through before choosing ARIMA. Some didn't even fit properly. It was not properly fitting with the seasonality. ARIMA was the best one used. And then we continued on with ARIMA. Thank you.
Thank you very much, Isaiah. Colleagues, we do appreciate your questions, your contributions, your comments. And if we have not responded to your question that is in the Q&A, we still have an opportunity to interact and respond to that. Some are also asking whether we shall share the presentation with them. Yes, we shall share the presentation after this. I would want to ask our program area manager, Dr. Dick Chamler, to summarize and tell us the way forward, what next. Thank you.
Yes. Yes. I think we asked you earlier if you can actually text us your emails so that we do the testing of the email so as to have your inputs as well. So please, if you can either actually try to write your actual email address in the chat, or if you prefer in our email, I think we'll also appreciate, and we will be actually trying to have this automated alert email actually after here our call. So we have over 250 attendance in this webinar. It's a reflection of the interest in which Africa has on preparedness. And in the last year, the time we were launching our PROS flagship, we say that 2022, 2023 is a year of preparedness, because as you have heard, last year we had over 150 actually public health emergencies. Out of those, there were over 130 outbreaks and over 28, I think, humanitarian crises. Overall lessons there, it tells us clearly, actually we are not prepared. And if we be prepared, we will be able actually to have impact on the number of these public health emergencies in which have happened. In the past 2 years alone, we had public health emergencies of international concern. Talking about COVID, I'm also talking about Mpox. I haven't even talking here about polio, in which it has a label still of public health emergency of international concern. As a result, the better response, it comes from the better preparedness. And there are a number of global initiatives now in which you all have heard. Intergovernmental negotiation body is trying to negotiate a pandemic accord in which is new. It will have an impact for us and the generation. We have a lot of contentious issues in which are happening, and the WHO Afro is working with our member states, the ministries of health, and our African experts in order that to see our African inputs are considered in this global negotiation. We all interested with equity, and the definition of equity here, we are not talking only in terms of access, we are also talking about access to technology in order to help us to enhance the local productivity and the manufacturing. Therefore, a lot is happening globally. IHR amendments is happening. Up to now, there are over 300 proposed amendments in IHR. Is unthinkable. Half of articles of IHR now are proposed to be amended. There are addition of annexes and etc. Still, in order to actually strengthen preparedness. In WHO Afro, we purposely say preparedness, it shouldn't be at upstream level. We have to bring it on the ground to be closely linked actually with response. So we are prepared in order to respond. So if we are prepared in order to respond, we have to have the tools and the platforms in which it will enable us to be prepared on the ground. And the predictions and the risk calendar is one of them, in which we think if the country will be aware of what is coming, actually be able or to be properly prepared. So in terms of the next step here, I think we will take all your inputs, we will work on them. We will work with actually few countries in which we think I will be ready to participate on this. So we will actually reach out to our partners in the region, where the regional economic bodies now are becoming interested in health preparedness. As you know, we have SADC, we have EXA, we have WAHO, ECOWAS, and others, and our colleague Africa CDC, in which we already have the work plan in which we are collaborating with them. And after our country briefing, we are planning to have another briefing with our regional donors who we have already reached out. And I think we will email all of you to know actually on the dates in which our donors are actually interested to hear also on these initiatives. Therefore, a lot to come. And I'm depending on you, on your support, and all the best in strengthening preparedness. Merci beaucoup.
Thank you. Thank you very much, Dr. Dick, for those final remarks. I would really want to appreciate everybody who has participated in this meeting today, and also appreciate people, not just in Afro, but also colleagues from other regions who requested to join this meeting. We have also had colleagues who have worked behind the scene. We do appreciate your work, Dr. Bukare and the team of interpreters who have done a good job. We do appreciate all that. We'll be sharing the presentation with you, and also, as Dr. Dika said, you'll be getting emails. Let us continue in this conversation, this dialogue, so that we can be able to improve our preparedness. Otherwise, thank you very much. We consider this to have been a very successful webinar with over 250 participants. Thank you and have a blessed afternoon. Thank you.